So amplitude is the distance from midpoint to crest. Okay, so we probably need to talk about what each of these things are. So midpoint is the equilibrium position. And then the crest is the highest, but you could also do lowest point. Okay, so on the pendulum lab that we're going to do, the amplitude is going to be how far away from equilibrium does it go. Okay, that's the furthest away it goes will be the amplitude. So if you have a pendulum that looks kind of like this, here's the equilibrium point where it's hanging straight down, and you pull it back to some point, this point here would be amplitude. So it's how far you pull back. All right, Ashlyn, what about B? What's period? Good. So it's the time to complete one cycle. And I'm going to use another vocab word here. And that's oscillation. We'll get to that one in a second. So time to complete one full cycle, and it's measured in seconds because it's a time. Good. Brian, what do you got for C, equilibrium?
In general, a state of balance. For mechanical equilibrium, the state in which no net force and no net Hercules act. More generally, the state in which no net change of energy occurs. There was one more part, but I can't write it since I don't have more space.
Fair enough. So state of balance it talks about, but it also talks about where the net force is zero. Okay, so on my pendulum example here, equilibrium is where the pendulum hangs straight down. Because that's where the net force is zero. That's where it's balanced. Okay? D, Mia, what about that one? Oscillation.
I put standard vibration when feeding to and fro motion about an equilibrium position refers to periodic motion.
Good. So it's a repeated to and fro or back and forth. About some equilibrium. So again, I've been kind of drawing diagrams for this. So equilibrium is straight down. So an oscillation would be going from one side to the other side and back again. So that would be one oscillation. It's a back and forth motion about some equilibrium position. So it goes from one side of equilibrium to the other side of equilibrium and then back again. All right, here's the last one, E. This one I'm going to do here. So restoring force. So restoring force is the force that works to return an oscillator to equilibrium. So there's going to be some force that's acting, and that force is trying to get back to equilibrium, and that's called the restoring force. Okay? There we go. So those are some basic definitions that we need to kind of do the rest of these to get our way through the lab. Okay? Any questions there? All right. So far, so good.